Part L, Graphical Transformations of Trig Functions. Before we go through this, take a look at the notes in the packet that review how amplitude and period work. We're going to be looking at graphs in the form y equals a times the sine, or cosine or tangent, or any of the other trig functions, of b times x minus h plus k. For a sine or cosine graph, the amplitude will be the absolute value of a. In a tangent or cotangent or secant or cosecant graph, the a value will just give us our vertical stretch. The period can be found by doing the normal period divided by the absolute value of our b function, of our b value rather. In a sine, cosine, secant, or cosecant graph, the normal period is 2 pi. In a tangent or cotangent function, the normal period is pi. And this is pi for a tangent or cotangent function. The h and the k are our normal horizontal and vertical shifts. What we're going to do to graph these is we're going to determine the parent function. We're going to try to immediately apply our new amplitude and period and sketch the new function, and then when we're done, we'll deal with any vertical or horizontal shifts. The first example we're going to look at is y equals 3 times the sine of 2x. My amplitude over here is 3, and my period is, well, this is a sine, so my normal period would be 2 pi, so the period here is going to be 2 pi divided by 2, or pi. What this means is my normal sine graph that starts at 0, goes to the highest point to 0, to the lowest point back to 0. I need to do that entire pattern between 0 and pi. I'm going to do some subdividing to be able to figure this out. I know at the beginning I need to be at 0, and I know at the end, after pi units, I also need to be at 0. Halfway through my sine curve, I need to be again on the x-axis at 0. Halfway between those first 2 points, I should be at my highest y value, or 3, and halfway between the last 2 points, I should be at my lowest y value, or negative 3. One period of this function looks like this. Now that I have that, I'm just going to extend it to fill my entire grid. Y equals 3 sine 2x will look like this. Next, let's take a look at y equals negative 2 cosine 4x plus 1. My amplitude is the absolute value of negative 2, so positive 2. My period is my normal period of a cosine is 2 pi, so 2 pi divided by 4. My period is pi over 2. Rather than trying to do this whole graph all at once, I'm just going to start from y equals 2 times the cosine of 4x. Then I'll apply the negative, then I'll deal with the plus 1. Well, my normal cosine graph starts at the highest point to 0, to the lowest point to 0, to the highest point. I need to do this entire pattern between 0 and pi over 2. At the start, I have to be at my highest value, and at the end, at pi over 2, I also need to be at my highest value. Halfway between, I should be at my lowest value, so negative 2. Halfway between the first 2 points, I should be at 0, and the last 2, I should be at 0. So one period will look like this. Continuing this pattern, let's see here. I'm going to get something that looks sort of like this. Now I need to deal with that negative, which is going to take my graph and it's going to flip it over the x-axis. So y equals negative 2 cosine 4x We'll take this point at 2 and flip it down to -2. We'll take my point at -2, flip it up to +2, and I'll just continue that way. It's getting a little bit complicated looking over here with two things at once. Finally, I need to deal with moving that graph up 1 unit. Y equals -2 times the cosine of 4x plus 1. I'm going to take all my points, move them up 1. So if I was at 2, I'm now at 3. If I was at 0, I'm now at 1. And if I was at -2, I'm now at -1. This black graph will be my final graph for this one. Next, let's take a look at y equals the tangent of pi x minus 2. I'm going to start from just y equals the tangent of pi x. I don't have amplitude with tangent graphs, but I do have a period. The normal period of the tangent is pi, so the period here will be pi over pi. The period should just be 1. I need to do my entire tangent graph over a span of 1 unit. Normally, it's centered on the y-axis, and it's still going to be centered on the y-axis. And I'm going to do my pattern between -1/2 and +1/2. I'm horizontally compressing my tangent by a factor of pi. One piece will look like that. I'm going to continue with vertical asymptotes halfway between all my integers on the x-axis. Then, all I'm going to do is move everything down 2 units. So y equals the tangent of pi x minus 2. The asymptotes will stay where they are, but those points that were at a height of 0 are now going to be at -2. So something sort of like this. One more graph. Let's take a look at y equals the secant of x minus pi over 2 plus 1. Well, I'm going to try to start from a regular secant, but actually I'd have an easier time starting from a cosine. So I'm just going to do y equals the cosine of x just to get a good start here. Doing my reciprocals to get y equals the secant of x. I get 1 vertical asymptote, -1 vertical asymptote, 1. Same deal continuing back in the other direction. And now I'm going to deal with my transformations. There's a horizontal transformation of pi over 2 and a vertical transformation of 1. So the secant of x minus pi over 2 plus 1, I'm just going to take my points, move them right one space, that would be pi over 2 units, and up 1. I think actually first I'm going to take my vertical asymptotes and transform those. Those will all be moved over 1 to the right. And now I've got over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. The black graph that I'm sketching right now is what the final graph should look like.